So this video is about a startup procedure for installing a typical Omega chassis. If the hoses aren't connected, the first step would be to connect the hoses as demonstrated. First, you want to finger tighten the hose to the fittings. Once hoses have been finger tightened, use your wrenches to go about a sixth of a turn, so one flat to one flat with the NPSM fittings. Do not over tighten, do not go past the 1/6 turn. After hoses have been tightened with a backup wrench, turn on the valves and check for any drips or water leaks. If there's any drips, you can tighten the hoses a little bit further in case there isn't a proper seal. The next step is going to be to slide the chassis fully in. After the chassis has been slid into the cabinet, take the control and power harnesses and connect them to the electrical mating connections. Just keep in mind that the harnesses have clips, and when removing the harnesses, ensure you depress the little button to get the harnesses out. Once the control wiring and the chassis harness have been connected, assuming the power wiring has been done by an electrician, check the thermostat wiring. You'll see on the wiring harness supplied with your unit, in most cases, you'll have a red, green, blue, white, black, and brown wires. By removing the Phoenix connectors, shows the thermostat connection points of R, G, Y, O, B, and C. The factory standard, red's connected to R, green to G, blue to G2, white to Y, black to OB, and brown is common. Using the other end of the thermostat harness, you can wire nut the thermostat cable to the pigtail. Wiring the thermostat G wires to the G1, G2, or G3 terminals will define the fan speed if the control board is set to auto mode. The auto mode is set on the dip switch settings, number 6 on the far right. With the dip switch slider at the top, or slid to the top, the thermostat is controls the fan speed. To use the unit's mounted speed selector switch, set the dip switch to the off position. Once the thermostat wires have been connected, check the condensate jumper has been installed, or if optional, condensate float switch has been installed. You should see harness connections here at the bottom of the board. The next step is to check the wiring of the thermostat. This is an Emerson Rogers thermostat, 144 series or the 151 programmable type. First thing you would need to do is jumper Y with W. Then you would connect up our thermostat harness or the thermostat cable to the appropriate terminals. So in this case we have red going to R, we have white going to Y, the black reversing valve wire is wired to the O terminal for energize to cool, and we have green going to fan. We have two fan speeds, green and blue. In this case we have only the green wire wired. This is a single speed thermostat. The blue wire is not used, and common is also not used with this type of thermostat, which would be the brown wire. Finally, install the chassis service panel and the electrical cover panels. This part of the setup, we're going to talk about setting the thermostat to cooling and heating to get the unit to operate in those modes, just to make sure that we're operating in cooling and heating. So for cooling, you're going to set your thermostat to cool mode, set your set point below the room temperature set point, and wait for the unit to run in cooling. For heating, do the opposite. set your thermostat above the room temperature to activate the heating mode. The other item that we're going to talk about is how to take temperature readings from the web-based platform inside the controller without having to use thermocouples on the unit. Typically, we recommend using a mini router such as this TP-Link router. It can be found on Amazon. We have details in our IOM on the product model number. When you're setting up the router, make sure you set it up as an access point router. And that's the main setup feature that you need to do with this router. Once you've done that, you can connect the router to the control board at the Ethernet plug, power your router, and connect to the router using your tablet or your smartphone. With these readings, you can take a screenshot and save that in a file. We see a lot of service contractors on startups going about this method to sort of data log each unit. And finally, on the control board, you'll have a status LED, which is the green blinking LED. Any red LED gives you information on the status of any of the sensors. Red blinking or red solid will define some sort of fault. Refer to the LED code guide for more information on what they mean.